Imagine discovering that the two most powerful technology companies on Earth have been engaged in a secret technical rivalry so intense, so strategically consequential, that one of them deliberately chose to suppress a quantum computing discovery for 2 full years, rather than let the other company know what direction to look. Not suppress it from the public for safety reasons. Not delay it for regulatory reasons. Hide it specifically because revealing it would have handed Microsoft the roadmap to close a quantum computing gap that Google had spent billions of dollars and years of engineering work to create. And now Microsoft found it anyway, not because Google made a mistake, not because someone leaked a document, but because Microsoft's own quantum research team independently arrived at the same discovery through a completely different technical path, and when they compared notes with what Google had quietly filed in patent applications, buried inside thousands of other filings, the match was exact. Same discovery. Different. Teams. 2 years apart. And the implications of what both companies now know they are both holding is sending shockwaves through every quantum computing laboratory on Earth right now in 2026. To understand why this hidden discovery matters so much, you first need to understand the specific technical race that Google and Microsoft have been running inside quantum computing, and why the gap between their approaches has been the single most important unresolved question in the entire field. Google's quantum strategy has been built around superconducting qubits, the approach powering its Willow chip that demonstrated verified quantum advantage in 2024. Superconducting qubits are fast, scalable, and backed by years of Google engineering investment. But they have one fundamental weakness that has haunted Google's quantum program since the beginning. They are extraordinarily fragile. Superconducting qubits lose their quantum state, a process called decoherence, so quickly that error correction becomes one of the most computationally expensive problems in the entire system. Google has been working on this problem for years and has made real progress, but the progress has come at enormous cost in additional qubits, dedicated entirely to error correction rather than actual computation. Microsoft chose a completely different path. Microsoft's topological qubit approach, built on a new class of materials called topological superconductors, promises qubits that are naturally resistant to decoherence at the hardware level, eliminating the need for the massive error correction overhead that consumes so much of Google's quantum resources. The trade-off was that topological qubits were significantly harder to build and took years longer to demonstrate, until Microsoft's Majorana chip announcement in 2026 showed that the approach actually works. And somewhere inside the gap between Google's error correction problem and Microsoft's topological solution is the discovery that Google buried and Microsoft just found independently. If the idea that both companies are now holding the same quantum discovery that one of them tried to keep secret does not make you want to understand exactly what that discovery is, hit like and subscribe right now, because the technical details reveal why this specific finding changes the competitive landscape in a way neither company has publicly acknowledged. So what exactly is the discovery, and why did Google choose to hide it rather than publish it? Everything centers on a specific property of quantum error correction that researchers have been calling the threshold crossing problem. For quantum computers to be commercially useful, their error rates need to fall below a specific mathematical threshold at which error correction systems can compensate for mistakes faster than those mistakes accumulate. Above the threshold, errors compound, the computation fails. Below it, the system becomes fault-tolerant and genuinely useful for real-world problems. Google's internal research team discovered in late 2023 that a specific combination of qubit geometry and error correction protocol produced threshold crossing behavior at a scale significantly smaller than the theoretical models predicted would be required. In plain terms, Google found a shortcut to fault-tolerant quantum computing that made the milestone achievable years earlier than the field's consensus timeline suggested. And Google did not publish it. They filed it inside a dense technical patent application, surrounded by dozens of other filings, specifically designed to make the core finding difficult to identify. Microsoft's quantum team, working on the same threshold crossing problem from the topological qubit direction, independently derived the same geometric insight in early 2026, and immediately recognized when they reviewed Google's patent landscape that the finding was already there, buried and waiting. Read that again. Google found the shortcut to fault-tolerant quantum computing in 2023 and hid it. Microsoft found the same shortcut in 2026 and immediately understood what Google had done. The competitive implications of both companies now holding this knowledge are significant in ways that neither has publicly addressed. Google's 2-year head start on implementing the threshold. Crossing insight inside its superconducting qubit architecture means it may already be significantly further along the path to fault-tolerant quantum computing than any public announcement has suggested. The quantum milestone demonstrations Google has published since 2023 may represent only the publicly shareable portion of progress that has actually moved significantly faster internally. Microsoft's independent discovery of the same insight means the head start advantage Google built through secrecy has now been eliminated. Both companies are now working from the same fundamental understanding of how to cross the fault tolerance threshold, with different hardware approaches and different implementation timelines, but the same core roadmap. And the race that was previously hidden is now, whether either company acknowledges it publicly or not, fully joined. Here is what nobody is explaining to regular people about why a hidden quantum discovery between two technology giants matters for their daily lives in ways that go beyond corporate competition. The timeline to fault-tolerant quantum computing determines when quantum computers become powerful enough to break current encryption standards. Google's 2-year hidden head start on the threshold. Crossing insight means the Q-day timeline, the moment when quantum computers can crack standard encryption, may be 2 years closer than the public estimates that cybersecurity planners, financial institutions, and government agencies have been using to set their transition deadlines. If Google has been running on an accelerated internal timeline while the public timeline remained unchanged, every organization that has been planning its post-quantum security transition based on public estimates is operating with a 2-year gap in its planning assumptions. That gap is not abstract. It is the difference between completing a security transition before quantum computers can break current encryption or after. The bottom line is this: Microsoft did not just find a quantum discovery. It found evidence that the quantum computing race has been moving faster than the public has been told, and that one of the most consequential technical insights in the history of the field was deliberately obscured by the company that found it first. The competitive dynamics between Google and Microsoft in quantum computing are no longer about who has better hardware or more qubits or more elegant architecture. They are about who can implement a shared fundamental insight faster across different technical approaches, with the full knowledge that the other side now has the same map. The race just got significantly more urgent and significantly more honest, and the world deserves to understand what is actually being raced toward before the finish line arrives without warning. Hit the like button and subscribe to Quantum Pulse, because this is exactly the kind of story that defines which companies win the next decade and which ones get left behind.